Namaskar friends, welcome to this session 15 on our course on processing of polymers and polymer based composites. If you remember, just to revise what we have covered in the course till today, we have covered the polymers, the basic fundamental classification of the polymers, that is thermoset and thermoplastic, the properties of the polymers, very fundamental information, very basic information, and then we have covered the different processes that are used for processing of polymers. If you remember, we have covered the casting process as applied to the plastics processing, then we have covered thermoforming, we have covered extrusion, we have covered compression molding, injection molding, also we have covered other processes like blow molding, which are very commercially used, and transfer molding we have covered. So by now I think all the learners have a fair amount of idea that what are the processing routes, techniques, fabrication processes that are followed for processing of polymers. Now in the last session we have shifted our attention from neat polymers to polymer based composites, and in the last session I have just given an introductory aspect of the composites, that is what is a composite material actually. We have seen two definitions of composite materials and we have tried to understand that there are broadly two constituents in a composite material. Now what are these two constituents? That these two constituents are, one is a matrix, another one is a reinforcement. So these two constituents are combined together to make a third material which has properties which is a best combination of the best properties of both the constituents. So we have tried to understand the basic concept of composite material, that why do we need to develop a composite material, what is the need for developing a composite material, and we have also understood what are the advantages of the composite material, and we have seen that for lightweight application composites have been developed worldwide and they find lot of applications in the aircraft industry, automotive industry, and there are number of other applications like biomedical industry, sports equipment, even household items are today being made by composite materials. So last class focused on the basic aspect of composite, that why do we need to combine the two different materials which are physically different, which are chemically different, to form a third material. So that was the basic concept, and if you remember we have taken an example of the RCC structure or our roofs also, in which we have metallic rods and concrete, that what is the purpose of combining the metallic rods and the concrete to make a structure. Today our focus would primarily be on the classification, because composite material is a very big family. There are a lot of research scientists or engineers who are working in the field of composite material, but we have to see that what is the broad classification, how the composites can be classified. Now classified means that what is the bigger family, that is a composite, then dividing them into its individual subfamilies and then the further subfamilies, so subfamilies. So we have to see how the composite materials are classified. For all composite materials, for all practical purposes, two constituents will remain same that we have discussed in the previous class, that is one will be the matrix, another one will be the reinforcement, and the matrix will have its own role to play. In the last session we have seen what is the major role of a matrix. It provides the bulk to the composite, it is a continuous phase, as well as it supports the fibers or the reinforcement. Moreover, it leads to the transfer, or it acts as a medium for the transfer of load when the load is applied on the composite material among the fibers that are used as the reinforcing elements. So matrix has got its own application or own role, as well as the reinforcement, as the name suggests, reinforcement has got its own role. So in the composite material, matrix plays its own role, reinforcement plays its own role, and when they combine together they make a composite, and that composite has specific applications. Now how the composites can be classified, that we are going to cover today. So let us start our discussion with the important point. If you remember, and I feel that all of the learners should remember, that what was the assignment that I have given to you in the last class, that is you have to find out that in naturally occurring composites what is the matrix and what is the reinforcement. So that all of you must have just looked into, or if you have not looked into, I have put together the composition of the natural composites, that is wood. So let us see. So there are naturally occurring composites, all of you know. Now what are these naturally occurring composites? Wood is one naturally occurring composite. Our bones are naturally occurring composite, and if you look around you in nature, you will find a number of materials which have this property of a matrix and a reinforcement, or two constituents or three constituents joined together to make a third material, but that has been developed naturally. So but the broad we can say the fundamental remains same, that there is a combination of two or three materials for making a third or fourth material which is better in properties. So the naturally occurring composites, wood is one example. In this case, matrix is lignin and the fiber is hemicellulose. So there is a fiber, there is a matrix, and they are combined together, and these combination of these two things, lignin and hemicellulose, lead to the development of specific properties in wood, and their relative proportion may change. Somewhere we may have different composition, lignin may be of a different amount, hemicellulose may also vary depending upon the nature, the tropical condition. There will be slight variation in these things, and therefore there are properties of the wood also are different. If you see that the wood that is used for making furniture is different, the wood that is used for making maybe some other application, maybe a handle of a wooden handle of a particular instrument, that is different. So the wooden applications are also different. Why are they different? Because of the properties. Why the properties are different? Because of the constituents, and these constituents may be present in relative amount. Somewhere one constituent may be in larger amount, the other may be in a slightly smaller amount. So basically we need to understand that there are two or three major constituents that add up to make wood, and that defines the properties of the wood. And in the last class or last session, if you remember, we have clearly tried to understand that how we can differentiate between an alloy and a composite, and what are the three major criteria which a material should satisfy to be classified as a composite material. So that is a very common question. If you will tell somebody, I have undergone a course on polymer composites, or I have information on polymer composite, the first question that you will be asked is how to differentiate between an alloy and a composite, and how to differentiate between a polymer and a polymer blend, how to differentiate between a polymer blend and a polymer composite. So these are some issues which are usually asked from the students, and that answer you should frame in your minds after going through these sessions, particularly the previous session in which we have tried to see that how you can classify a material as a composite. Classify means what is the criteria based on which you will say that this is a composite material. And if you remember, the 5% critical limit was there, that both the constituents should be present in appreciable amounts, but the lower constituent or the lower quantity constituent must be above at least 5%. So that was one condition. Other condition was that the two constituents do not chemically are soluble into each other, they are insoluble into each other, and there is an interface that separates the matrix and the reinforcement. So there are certain guidelines, certain hints which will help you to differentiate an alloy from a composite material. So that is the information that you should always keep. And here also somebody may say, bring a different material which has two or three constituents, and may ask you whether we can make this, or we can classify this material as a composite material. You should look at those criteria. If those criteria or those criterion are being satisfied, then only you can say that yes, we can classify it as a, or we can term it or name it or define it as a composite material. Now there can be a question that you have a substrate or a base material and you do a coating on that base material. Now somebody may say, now there are two constituents, one is a coating, another one is a substrate, this can be called as a composite material. No, we cannot say that it is a composite material. Why? Because in one has to be a continuous phase. So here there are two different constituents, but there is no continuity of any phase in this thing. So we can say yes, it is a coating on a substrate, but we can't classify it as a composite material, but there is no continuity of any material, of any of the constituents. So there are few, we can say, gray areas where we need to focus and try to understand that what exactly are the composite materials, and there is lot of, we can say, debate going around to classify or define composite materials clearly, so that learner has clear idea that this is a composite material and this is not a composite material. So that is the purpose of defining or going through this today's session, in which we will see how to classify a material. So first classification on your screen, one is natural composite, another one is synthetic composite. So if you are asked that what are the different types of natural composites, two examples should immediately come to your minds, that is first one is wood and second one is the bones. So these are two naturally occurring composites. But if you talk about the synthetic composites, it is a very big family, and still people are developing new and new combinations of matrix and reinforcement and coming up with new and new types of composite material. So synthetic composites is a very large family, and naturally occurring composites is a very small family. Now synthetic composites, on your screen you can have a classification, synthetic composite materials. This classification is the most commonly adopted classification for composite materials. Now in this classification you can see that we can classify the composite materials based on the matrix that is used for making the composite. And here you can see, as the name suggests, polymer matrix composite, metal matrix composites, ceramic matrix composites. So you should remember that based on the two constituents you have a classification. Based on the matrix you can classify them as polymer matrix, ceramic matrix and metal matrix composite, and each one of these will have their specific application areas. For example, I may ask you, this is a common sense question, that for high temperature applications which type of composite you will suggest? Now immediately the answer should come that ceramic matrix composites, but ceramics are used for high temperature applications. And if I ask you that for low temperature applications which is the composite material you will suggest, immediately the answer should be polymer matrix composite, because polymers have low melting point, they have very low glass transition temperature. So we have to see that what type of material is suitable for what type of application. So based on their application or based on the matrix that is being used, we can say, we can classify them as polymer matrix, metal matrix and ceramic matrix composites. Based on matrix, you can see on the screen we have polymer matrix, ceramic matrix and metal matrix. But based on reinforcement also there is a classification. Now based on the reinforcement we can classify them based on the shape of the reinforcement. Now shape can be continuous, it can be long fibers running in the polymer matrix or long fibers running in a metallic matrix, so that the shape of the reinforcement can be continuous, that is one thing. Then you can have short fibers. In many applications, especially injection molding machine is used for making short fiber reinforced polymer composites. So you can have reinforcement in the form of short fibers. You can have reinforcement in the form of whiskers. In the last class we have seen that whiskers can be randomly oriented through the matrix. Whiskers can be oriented or they can be having a directional orientation within the matrix. So you can have whiskers as a reinforcement, definitely they will have some aspect ratio. And finally the particulates. So you can have fine particles as the reinforcing elements or reinforcing agents in a metallic or a ceramic matrix, as well as in a polymer matrix also sometimes. Sometimes nanoparticles or nano reinforcements are used to reinforce the material or to improve the mechanical as well as the other properties like thermal or the chemical properties. Many times electrical properties can also be improved or enhanced by the addition of the reinforcement. So it's not only that reinforcement is added only for the mechanical properties or for improvement of mechanical properties, reinforcement is also sometimes added in order to improve the other maybe properties such as electrical as well as thermal properties. So we can see based on the shape of the reinforcement we can have continuous fibers as the reinforcement, we can have short fibers, we can have whiskers, we can have particulates. So one assignment that is there for you, now you should remember that what is the difference between a short fiber and a whisker, that you should keep in mind and try to figure out the answer to this particular question. So what is the difference between a short fiber and a whisker? Because continuous fibers absolutely clear. Particles, absolutely clear. So there is a gray area between the short fibers and whiskers that you have to figure out and find out through literature. Now, based on the orientation of the reinforcement in the matrix, as I have told you, you can have all fibers oriented in one direction, or you can have randomly oriented fibers in the matrix. So orientation also plays a significant role in defining the properties of the resultant composite. That has to be taken into account, that what is the orientation of the reinforcement in the matrix. Similarly, based on the chemical nature of the reinforcement, we can have oxide like aluminum oxide, we can have carbides like silicon carbide, as well as we can have nitrides, and this list is endless. You can have other ceramics or other types of materials also which can be used as the reinforcing elements. So you can see that you have a matrix which can be polymeric, which can be ceramic, which can be metallic. You have a reinforcement which can be classified based on its shape, based on its orientation, and based on its chemical nature. So this is one important classification of composite material that is there. Now simple examples can be put into this. Now let us take one or two examples. The first example that comes to my mind is a glass fiber reinforced plastic, GFRP, most commonly used type of a polymer matrix composite or a fiber reinforced plastic. So these two names are used interchangeably, that is polymer matrix composites as well as fiber reinforced plastics. Now example that we have taken is a glass fiber reinforced plastic, GFRP. Now what is the matrix here? Because fibers are used for reinforcing or for the purpose of reinforcement. So glass fiber reinforced plastic means that plastic is the matrix here. So in our diagram we can see the matrix is a polymer matrix. Now the reinforcement is glass fiber, the reinforcement is glass fiber. Now the glass fiber can be continuous glass fiber, it can be in the form of short fibers, it can be in the form of whiskers. So we have to see that what is the shape of the reinforcement. Then the fibers are oriented. If they are long fibers, they are oriented in one direction only. We will say from the orientation point of view, the reinforcement is oriented and it is in one direction only. Then the chemical nature also, we can, in this case we are not bothered much about the chemical nature, but in glass fiber reinforced polymer we know that the matrix is polymer and the reinforcement is long fibers and the orientation is oriented in one particular direction. So that is one thing that has to be taken into account. So that is the broad classification. Let us take another example of a metal matrix composite. Now suppose we have aluminium as the metal, aluminium as the metal or the matrix. So your matrix is aluminium, that therefore it falls under the category of metal matrix composite. Now the metal is your metal is your matrix. Reinforcement suppose is silicon carbide and it is available in the particulate form. So from the reinforcement point of view we are taking silicon carbide. Now silicon carbide, from shape point of view we are using particles of silicon carbide. Then we have orientation, we can have random orientation of the silicon carbide particles in the aluminium matrix, and finally the chemical nature. So we are using carbides, that is silicon carbide. So another example of metal matrix composite can be aluminium matrix composite reinforced with silicon carbide, or aluminium silicon carbide composite in which the matrix is aluminium and the reinforcement is silicon carbide particles. So this broad classification diagram gives you so many different examples. Maybe in the assignment you can take 5 different examples, you can search and you can try to figure out 5 different types of composite materials and then try to put them into this diagram, that what is the matrix, it is either it is polymer or it is ceramic or it is metal. What is the reinforcement, whether the reinforcement is based on shape, is continuous or it is short or it is particle or it is whisker. Then from orientation point of view you can classify, and then from the chemical nature point of view you can classify. So if you do that exercise you will be very easily able to classify the composite materials. As the title of our course is polymers or processing of polymers and polymer composites, now we enter into the exact domain, that is polymer composites. Now As I have told you, these composites, basically polymer based composites, are also called fiber reinforced plastics because the matrix is plastic or polymer and reinforcement is in the form of fibers, especially in case of polymer based composites. So we usually call them fiber reinforced polymer composites also. And here again we can see the examples. As I have told you, the last diagram was a generic diagram, a general diagram classification showing classification of composite material, but this is a specific diagram related to the polymer based composites only. So we can see from matrix point of view, we can have two types of polymers. One are thermosets and the thermoplastic, and this we have already covered in our course in the very beginning, I think in the second or the third session. So thermosets can be epoxy, polyester, polyamide. Thermoplastics can be polypropylene, polyethylene, polyvinyl chloride, polyether ether ketone, or ABS, that is acrylonitrile butadiene styrene. So we can have a thermoset matrix or a thermoplastic matrix, and must I address this point that depending upon the type of matrix, our properties will be different. You have a thermosetting matrix, the properties will be different. You have a thermoplastic matrix, the properties will be different. So from matrix point of view, in case of polymer composites, we can have thermosets and thermoplastic. Similarly, from reinforcement point of view, we can use synthetic fibers as the reinforcement, and we can also use the natural fibers as the reinforcement. From synthetic fibers point of view, we can have carbon, glass, Kevlar as the reinforcement. So Kevlar is basically aramid fiber. So the synthetic fibers, carbon, glass and Kevlar. From the natural fiber side, we can have natural fibers, a long list, and we will try to address it if possible in our course. What are the different types of natural fibers, how they can be classified, how they are derived, what are the sources of different types of naturally occurring fibers. But okay, from just to introduce the concept of polymer composites, we can have matrix, that is thermosets or thermoplastic, and we can have reinforcement, that is a synthetic fiber and a natural fiber. From natural fiber, mostly occurring are jute, banana, sisal fiber. Then again, we can have natural fiber reinforced polymer composites also, in which the natural fibers are used as reinforcement, and we are all around the world there is a trend towards biodegradable composites, in which the polymer or the matrix is also biodegradable, as well as the fibers or the reinforcing members are also biodegradable. So natural fiber reinforced polymer composites we can see here. We can have partially green composites. We can have in partially green composites, we will have natural fibers with non-biodegradable polymers. So the reinforcing agent, that is the fibers, are biodegradable or naturally occurring, but the polymer or the matrix is not biodegradable, it is a synthetic matrix, as we have seen in our previous slide, that thermoset and thermoplastic matrices are there. Suppose we use a thermoset and we use epoxy as the matrix, so it is non-biodegradable. If we use thermoplastic and we use polypropylene or polyethylene as a matrix material, it is non-biodegradable, but the fibers actually are biodegradable. So then we get partially green composites. But what is the trend? The trend is towards fully green composites. So for fully green composites, we should have natural fibers with biodegradable polymers. So our polymer or the matrix should also be biodegradable, our fibers should also be naturally occurring, and then we can have hybrid green composites, that is another category of composite materials. So broadly we can say, if we use natural fiber as the reinforcement, we can at least get partially biodegradable composites, and if we can have the liberty of choosing the matrix material also which is biodegradable or a biopolymer, then we can have the advantage of making a fully biodegradable composite material, because the reinforcement material is also naturally occurring or derived from nature. Now on your screen you can see the different types of synthetic fibers. You can have glass fiber, the Kevlar fiber, Kevlar carbon, hybrid fiber, in which in one direction we have maybe black portion is the carbon fiber, the blue portion is the Kevlar fiber. So we can have hybrid also in one direction and the other direction, longitudinal and the transverse. Basically this is called warp and weft in textile technology, that in one direction the fiber is called warp and another direction of the fibers is called weft. So here we can have different fibers in warp and different fibers in weft, so that basically gives us a hybrid type of fibers which can be used as a reinforcement in case of polymer composites. And we can have neat carbon fibers, woven carbon fibers, woven glass fibers, woven Kevlar fibers. So this is all, these are synthetic fibers, and these days even people are trying to attract or to get the best properties, people are taking natural fiber in one direction, maybe warp or weft, and the synthetic fiber in other direction. That is also possible, and that type of hybrid fibers are also available, which can be used as reinforcement for reinforcing the polymer matrix. So lot of research work is going on. Even the weaving pattern, people are working all around the globe to find out that which is the best weaving pattern for a particular combination of fiber, so that we get the best properties when we use these as the reinforcing elements or reinforcing members in polymer based composites. On your screen, this is a list showing different types of natural fibers. They are in the raw form, they can be woven into the matte form, and then the matte can be used as a reinforcement for making natural fiber reinforced laminated composites. But this is just showing the raw type of fibers which are available, and these have been derived from nature. And once we have the natural fibers, we have the polymers which are readily available, we can make a composite material. On your screen you can see the fiber, when the raw fiber which was shown in the previous form, when it is woven in the form of a mat, this is a woven natural fiber mat, and this can be used as a reinforcement agent, and this is the polymer pellets, thermoplastic polymer pellets, and when we can combine them together, we can make engineering materials like this, and these are the composite materials which can be used for various engineering applications. So here we can see the natural fiber is acting as a reinforcement member for the polymer, and we are making a composite material, and the composite on your screen is shown here. So you can see that a fiber and a polymer have combined together to make a third material which can be used for various engineering applications. So this is, I think, the end of today's session. So we have tried to classify the composite materials based on the matrix. We have tried to classify the material based on the reinforcement. We have taken some examples that in this classification where which example can be we can fit in, and then we have tried to understand what are the different types of synthetic fibers. We have seen what are the different types of natural fibers and how they can be used for combining them with the polymers to make them a composite material. I think now the classification is absolutely clear to you, and we have taken a slight step towards our topic, that is processing of polymer composites by classifying the polymer based composite. We have seen what is the matrix. It can be thermoset, it can be thermoplastic. We have seen what can be the reinforcement. We have seen synthetic fibers as reinforcement. We have seen natural fibers as reinforcement. Now we will see the last slide gives us a glimpse as well as sets background for our further discussion, because now we have to understand that this plus sign which is on your screen, this plus sign seems to be very simple, but the color signifies its importance, that how now we can combine this fiber and the polymer together to make this composite material. So the whole discussion here on will focus on the processing routes, technologies, techniques for combining the fiber and the polymer into a composite, so that the properties that we get, that we have planned, that we have designed, the properties that we are able to get by adopting the best possible technique for combining the fiber and the polymer together. And the combination or the processing will depend on a number of parameters which we will be discussing one by one, stage by stage, phase by phase in our subsequent sessions. So with this we come to the end of today's session on classification of composite materials. Thank you.